Okay, so in the last video we got done till the enzyme inhibitors and these all cofactors and these all. In today's video we are going to look into lock and key model. So first thing, who introduced this model? That was Emil Fischer, who introduced this model in what year? In 1918. 98. This was introduced in 1898. Okay, so what does these models say? They just tell about the binding. So for what binding? Like they tell about the enzymes or the substrate or simply the models which we will be discussing, induced model and lock and key model. They just tell that enzymes or the binding. Enzyme binding, they all their attraction between them, how they are added between. So these models simply tells about this. So what does lock and key model specifically say? So if I just make this is the enzyme, here we have the substrate. So simply, which means like for every specifically lock we need to have a particular key. Not if we have the one lock and thousand of keys, then these all will be attached with that? Of course not. So for what? So here this is the enzyme, this would be the substrate. So this means for every lock there is specifically key. For this means for every enzyme we have a specific substrate which will be attached. Not every enzyme will literally attach with this, whereas particular enzyme will be attached. So we can call as like particular shape is required, particular structure. Lock and this word lock and key, simply word even tells that there would be an specifically, not every, but the specifically these would be attached. So we have particular shape, particular structure is required to be binded with this, and we have the active side is the middle part where these all will be attached. Here active side are rigid. What does this mean? Rigid is like non-flexible, which means if the active side, if we have this one enzyme and for its substrate we have the circle like structure, and this one is known as active side where it will attach. So active side is rigid. This means this is non-flexible, will not change its shape for any of the substrate. If this is round, so of course this will not bound with this one, this will not attach with this one enzyme. So what is this important? Like active side will change its shape? No, active side will not change. Flexible simply mean no change or no any change in their shape, no change in shape, structure, and these all. This mean, as we know, like for every key and for every lock we need to have a specific key for every lock. But if we have another, of course we cannot open that. For likewise, if we have the enzyme for active side or for substrate, we need to have particular shape. Active side is very rich. This means it will not change its shape, structure for any of the enzyme which is coming. I'm sure you are getting the concept. So we can also call substrate is simply known as lock, and substrate is lock, and enzyme, the down part, is known as key. How? If I have this one as it's a lock, so lock is known as substrate, and the key I will be inserting into it is this enzyme. So lock and key simply just tell that lock and key model tell that every substrate need to be fit in the enzyme shape, because active side will not change its shape, structure, just because for that substrate. So this was told by Emil Fischer in 1898. This was very important. Their particular shape, structure, That's why they're supposed to